For our science lesson, we'll be looking at Stage 3 Material World. Our outcome that we'll be focusing on is explains the effect of heat on properties and behaviours of materials. We have an inquiry question there, and this lesson will be broken up into two parts. First part will be a water cycle demonstration. The second part will be a saltwater versus freshwater evaporation experiment. Prior to this lesson, students have been studying the topic states of matter. So they have been taught that matter is everything that is around us, and atoms and compounds or particles are all made up of very small parts of matter. Students have also been studying the particle theory, so they understand that this states that all matter is made up of small particles which are constantly moving. And through this lesson, we'll also be seeing that they're categorized into three main states of matter, being solid, liquid, and gases. To ensure that students will be active participants throughout the whole lesson and not just the experiment phase, we have decided to use this app called Science Journal. So this app allows students to write down any observations they might have seen. They can record their own data, and it's all set within one file. And then they can also take photos of your work, as you can see demonstrated in one of the boxes on that slide. Although part one isn't necessarily the main part of this assignment, we thought it was necessary to include this as it sort of sets a foundation for the experiment. Due to time restraints, I won't go too in depth about the demonstration of the water cycle, but basically the teacher can explain how the key terms of condensation, evaporation, and precipitation, and how this works within our environment. The teacher may also set up a in-class demonstration that the teacher will do and show the children. So this isn't an experiment for the children to do, just because it will be too dangerous. But the students could observe, and using their app, they could take photos and they could write down their own observations of what they see in that water cycle. It is critical that students understand the link between the water cycle demonstration and the salt experiment. This is that in our environment, different types of water have different evaporation rates.
So for today's experiment, we're going to look at how liquids change states to gases and the various boiling points of different liquids. So first we're going to need a pot, a measuring jug, salt, electric scales, and a smaller measuring cup. Our dependent variable for this experiment will involve us measuring the percentage of a liquid's weight that is lost during boiling and how the addition of salt alters these results. So next, our independent variable, which is what is changed during the experiment, that is quite simply going to be the amount of salt that we add to the water. Our controlled variables which stay the same include our equipment, the weight of the water, the temperature of the pot which is boiling, and the temperature of the water when it starts. To begin with, we are going to place our measuring jug onto our scales, and we're going to try and measure exactly 250 grams of water. Next, we're going to pour the water into our pot on the stove and turn up the temperature to full. And next, we're going to make sure we set our timer for 4 minutes exactly. While the water's boiling, I'll ask students to observe what's happening on the surface of the water. Why is it bubbling, do we think? Is there any steam escaping off the top? So once the water's finished boiling for 4 minutes, we're going to come back to our measuring jug and pour it on the scales. Now we need to make sure that we record the weight of the liquid after it's finished boiling. So for our next variable, we're going to add 50 grams of salt to the water. During this process, I'd ask students to hypothesize what do they think will happen when we add the salt to the water. Do we think it will make the water evaporate faster or slower? And will this result in more or less water left when we measure the amount at the end? So now we are going to add our 50 grams of salt to our 250 grams of water. And we need to make sure that we mix the solution together really well and observe the starting weight of 300 grams. The next steps in the experiment will remain the same as our first test, making sure that we boil the water for exactly 4 minutes at the exact same temperature. Next, we'll pour the water back into the measuring jug and observe the weight. We are then going to repeat the experiment with 100 grams of salt this time. After we've completed this final time, we are then again going to repeat the whole experiment 3 times to ensure accuracy with our results. Throughout the boiling process, ensure the students notice what's occurring in the liquid where the water is escaping into a gas. Ask them to describe what they think is happening with the particles. Throughout the entire experiment, students have been recording their data in their science journal in the form of a table. They've been recording the weight of the solution initially, the weight after boiling, and then finally the weight difference divided by the initial weight, which then gives us a percentage of how much water is lost during the boiling process. Each of the times the experiment is repeated, the data is collected. And then finally, the data is put into one table showing the percentage of water lost during boiling. We can see that as more salt is added, the percentage of water lost during boiling decreases. So therefore, the composition of the liquid changes the boiling point, which is the temperature where the liquids begin to turn into a gas. So we can conclude that different liquids have different boiling points, and therefore change states from liquid to gas at different rates.
So where to now? You could take this lesson and then go more in depth about water vapor in the atmosphere and how it comes from the oceans, because the oceans covers about 70% of the Earth's surface. The salt contained in seawater is dissolved in the water but is not chemically bonded to it. This means that when seawater evaporates, only pure water returns to the atmosphere. Linked on that slide is a demonstration that shows exactly that. After that, you could also teach children about water conservation and build a big class project around that.